I wanted to take one nerd moment. So now we're going to have our nerd corner
Okay.
to, to dig in deeper on one topic that you mentioned that I've been fascinated to learn about. And I know there's some debate about it in the industry, which is contrails.
Mm-hmm.
So for our viewers who aren't familiar, contrails is short for condensation trails, and you've seen them. They're those white cloud streaks that you sometimes see trailing behind planes when they're flying at high altitudes. And this is an area of great interest because these contrails contribute to climate change because of the way that they trap heat in the Earth's atmosphere. And I know that there's a lot of research in the field of managing contrails, but some of the solutions involve changing flight paths or flying at higher or lower altitudes, which can also increase fuel usage. And so we think about how to manage the trade-offs. I know that I wanted to take time on this because I know how much our science team at Carbon Direct has done in this space, but I'd love to hear from you as a practitioner. How are you thinking about contrail management as a potential part of the solution, and maybe in the shorter term?
Well, and such an important question. So contrails, not every contrail is deemed equal. So there's some
Mm,
pretty nasty contrails out there that persist in the atmosphere and they trap the heat. And then there's a whole bunch of other contrails out there that are just fine and they dissipate and they go away and everything's fine.
mm,
The contrails that we care about are those that are at certain altitudes at certain humidity levels. And those are the ones that tend to trap the heat, usually at night, in certain geographies across the globe. And those are the ones where we need to be able to figure out, to your point, A, where are they? B, will they persist, which then causes the trapping? And then C, if we
mm,
modify right now, are we causing net benefit or net damage to the climate because we're actually emitting more CO2 into the atmosphere by burning fuel, which, as you know, lasts for
mhm,
hundreds of years instead of the 24 hours of the contrail.
mm,
So what is sort of the sort of net impact on the climate writ large from doing that modification? There is a tremendous amount of collaboration going on right now across
mm,
the industry here in the US with the FAA, with NASA, with the Department of Energy to really understand the science and the climate modeling to figure out exactly where those contrails that are the bad ones form
mm,
and persist. Can we figure out with more accuracy than we have today so that we know it's worth it for us to deviate? We're also
mhm,
involved in several initiatives, research initiatives right now. For example, working with NASA and Boeing with their Eco Demonstrator project to actually test if you have SAF in one engine at 100% and conventional jet in the other engine at 100%, do you see contrails forming with the SAF engine? And the answer is yes, but materially less. And there'll be some research coming out later on this year around that. So
interesting.
yet another benefit of the adoption of 100% SAF. We're now
Hmm.
partnering with NOAA to put sensors on some of our aircraft. So not only can we do methane detection in some urban areas to figure out where there's leaks, but we can also sense for that humidity. So we can actually start informing those models and making them smarter so that we can actually detect where these persistent nasty contrails are and let the other ones go. So, there's a lot of discussion around what is the right engagement to
Hmm.
address contrails such that we don't have an adverse effect that was not anticipated. The other part of the solutioning is that it's got to be a system-wide fix. So if
Hmm.
United flies a path and we're told to deviate some degree so that we don't cause or don't hit that patch where there's persistent contrails and we end up deviating, but the airline behind us goes right through that original path, the warming happens. So what's that compounding if one
Hmm.
modifies but the other doesn't? It's got to be a system-wide solution. So can we think of it in the context of air traffic control or all
Yeah.
operators working together so that we actually do solve and don't actually make it worse because we're adding CO2 and we have the persistent contrail. We do not want that. So there's
Right.
a lot to learn, but it's so, so important. And I'm really pleased with sort of the focus on the science and the research
Hmm.
that we can
Hmm.
actually move to action. Like that is what it is. How do we activate a solution so that we can make sure that how we're mitigating contrail formation is actually effective.
This is really interesting. So one thing that I'm hearing is whenever I see a contrail in the sky, I don't need to worry. It's only some of them.
It's only a few of them.
And it sounds like there's active research in this space, a lot still to learn, but that this will be a part of the portfolio of solutions one day.
Absolutely. It has to be.
Yeah,
Absolutely.
yeah. Fascinating.